Now please confirm to me. I'll forget my voice on screen. Those who are attending in online, guys. Now please confirm to me. I'll forget my voice on screen. Those who are attending in online. Am I audible? Guys, now please check it. I'll forget my voice on screen. Those who are attending in online. Am I audible? Is my voice on screen is clear to all of you guys? Now please confirm to me. Am I audible? Guys, now please confirm to me. I'll forget my voice on screen. Those who are attending in online. Am I audible? Am I audible, guys? Please respond to me. All of you know. Right. Good morning, guys. Right, sir. Now, yesterday, just we understood the total Java history. And Java history, mainly the topics what we have seen there. Sun Microsystems wants to prepare a new programming language to prepare softwares for the electronic devices like remote controllers, cable TV switch boxes, and so on. For that, it gathered nearly 30 members team led by James Gosling and Patrick Norton and started a project with the name Green. That they want to maintain three features mainly: simple, tight coded, architectural neutral. Simple in the sense application should be in a less execution time, less memory, less energy consumption. Tight coded in the sense what there, less number of instructions and with more implementation. Then after this, architectural neutral in the sense able to run its applications under all the hardware systems. So now these are the features they have included under simple, tight coded and architectural neutral. After that, at the end of 1992, they prepared a programming language and they want to give a name to the new programming language. Initially, James Gosling has suggested a name, Oak, but it was rejected by Sun Microsystems. Why? Because it was already an existing programming language. So Sun Microsystems has not accepted that. Later, all Sundinis have suggested the name Java. Why? Because they used to take a brand labeled coffee at their cafeteria. That is Java. That's why they are given that option. Sun Microsystems has accepted that and they are given the name for the new programming language is what they Java. Alright, sir. That we understood. At the end of 1992, they prepared the first product on Java. That is what their Star 7. It was a failure product. No customer is identified. Sun Microsystems has waited nearly up to mid of 1994. In the mid of 1994, there was a boom for browsers. Browsers are getting very good demand. By the time, only one browser is available, that is Mosaic. It was provided by Mark Anderson. So as per this boom, as per this demand for browsers, Sun Microsystems wants to prepare their own browser. Right, that responsibility was given to Jonathan Payne and Patrick Norton. Then at the end of 1995, they prepared a new browser. Its name is what their hard Java browser. It was a successful product. Then demand is available for that hard Java browser. So later, Sun Microsystems wants to release Java programming language to the market. Alright, as per the demand for the customers. Then finally, they released it in 1996 January month. From that point onwards, every year, maybe every 2 years or 3 years of time, they try to release some new versions. Right from JDK 1.0, they started with that. So then one by one, all versions they started, they provided. As of now, at present, the latest version of the Java is what there, JDK 1.22. Okay, where some milestones are available, some changes are available. Right from JDK 1.0 to up to Java 1.6, Java was maintained by Sun Microsystems. Right from 1.7 onward, Java was maintained by Oracle Corporation. Up to JDK 1.10, Java versions are released yearly wise, 2 years once, 3 years once like. But from 1.11 version onwards, Java is released for every 6 months of time. A new version is provided by Oracle Corporation for every 6 months of time. So, moreover, JDK 1.11 version onward, the Java is what their licensed one. That to whom it is licensed one actually, it is licensed for corporate users, not for normal users, not for teachers, not for students, not for individual development. It is licensed for what their corporate users. They must take license for it. Right. So now the other points already we understood in the last session. Okay, fine. So now we are going to understand the second topic in introduction part, differences between Java and others. The very first difference here I am telling to you, observe carefully. The first difference is like what there, C and C++ are static programming languages, but Java is a dynamic programming languages. Java is a dynamic programming language. This is the very first point what I have given there. C and C++ are static programming languages, but Java is what there, a dynamic programming language. Okay. Now understand this point clearly. The next one is what there. Right, sir. Now I'm going to give some points about this first difference. No, understand it. For example, if you write a program, the program may be anything, C program or C++ program or Java program, whatever it may be. If you write a program, the program must be compiled. Am I right or not? The program must be compiled. After that, we'll get some file that we have to execute. Compilation, execution, two things are available. Compilation and execution. For what purpose we are performing compilation? Because of two reasons. One is error checking. If you do any mistake in our program, that must be identified, that must be checked. That is error checking. Second one is what? We are going to write the programs in a high level. We are going to write the programs in what their high level, but execution engine is required the program in a low level. Understand my point? We are able to write program in a high level syntax. Int I is equal to 10, but machine is going to execute our program. For that execution, the program is required in what their low level. That means zeros and ones only. So where to convert the program from high level to low level, we are going to use what there, that compilation process. Fine. Once we compile this program, the C program, if we compile the C program, there we are able to get .exe file. The .exe file here we have to export. By using execution engine, we are going to execute what there .exe file. There we are able to get some output. This is actual process here I'm telling you. But here the point what I'm telling to you, observe carefully. If we provide memory allocation for the data at a compilation time, what is it? If we provide memory allocation for the data at a compilation time, then that memory allocation is static memory allocation. If we provide memory allocation at a runtime, execution time, then that memory allocation is what there? Dynamic memory allocation. There are two types of memory allocations. Please remember it. Static memory allocation and a dynamic memory allocation. So what is static memory allocation? No. If the memory allocation is going on at compilation time, then that memory allocation is called what there? Static memory allocation. If the memory allocation is going on at runtime, then that memory allocation is what there? Dynamic memory allocation. Say for example, if I provide int a is equal to 10, for example, if I provide this, int a is equal to 10, observe carefully, all of you know. Now, a is a variable of type integer. So in C programming language, 2 bytes of memory must be allocated for a. Understand my point? If that memory allocation is provided at compilation time, if compiler is providing memory for a variable, then that is what their static memory allocation. If the memory is provided for a variable at runtime, then it is what there? Dynamic memory allocation. I'll forget my point or not? So the point is what I'm telling to you. If any programming language allows static memory allocation, that is the memory allocation is provided at a compilation time, then that programming language is called static programming language. The programming language is called what there? A static programming language. Alright, sir. Now, examples for static programming languages are C and C++. Come again, what is the static programming language? If any programming language allows static memory allocation. What is the meaning of the static memory allocation? That is, the memory allocation is provided at what time? No, compilation time. Then that programming language is called a static programming language. What is the example for static programming language? C and C++. Understand the point here I'm telling to you. In C and C++ applications, memory will be allocated for the data at a compilation time only. Memory will be allocated for the data at a compilation time only. Data in the sense what there? Int I is equal to 10, where 10 is a data, I is a variable. For that variable, for the 10, memory will be allocated at compilation time only in the case of C and C++. Because of that reason, C and C++ are what they? Static programming languages. These are like what they? Static programming languages. Observe carefully the point. After this, after completion of this, as it is, quite opposite of this is what their dynamic programming language. Quite opposite of this is what their dynamic programming language. What is the meaning of this dynamic programming language? Now tell me what we are understanding about the dynamic programming language. If any programming language is following dynamic memory allocation, not static memory allocation, dynamic memory allocation. That is, the memory allocation is provided at a runtime, not at compilation time. After writing the program, two things we have to do: compilation, execution. Compilation time is what their compile time. Execution time is what their runtime. Runtime is nothing but what their execution time. Then only we are able to get outputs actually. If the memory allocation is provided for the data at a runtime, then that memory allocation is called as what their dynamic memory allocation. I'll forget my point or not? If any programming language allows dynamic memory allocation, that is, the memory allocation is provided at a runtime of the application, then that programming language is called a dynamic programming language. The programming language is called what there? Dynamic programming language. First of all, now confirm to me, all of you are getting clarity on this point? All of you are getting clarity on this point? What is static programming language? Nothing. If the memory allocation is at compilation time, the programming language is what there? Static programming language. If the memory allocation is at runtime, that is at execution time, then the programming language is what there? Dynamic programming language. Alright, sir. Now, what is the example for dynamic programming language? The best example is what there? Java, Python, .NET. All these are what there? Dynamic programming languages only. But our concern is what there? Java. That's why Java is what there? A dynamic programming language. Now I'm giving clarity to you. Observe carefully. In Java applications, memory will be allocated for the data at a runtime of the applications. At a runtime only. Memory will not be allocated for the data at a compilation time. In Java, memory will be allocated for the data at what time? Runtime only. Guys, all of you are getting clarity on this? This is the very first difference between C, C++ and Java. C and C++ are what their static programming languages, but Java is what their a dynamic programming language. Getting clarity in this point, all of you know. Right, sir. Leave this point here. After this, after completion of this, the second point here, what I am telling to you, all of you observe carefully. Preprocessor is required in C and C++, but preprocessor is not required in Java. This is the second difference here we have to understand. Preprocessor is required in C and C++, but preprocessor is not required in Java. Right, sir. So first we have to understand what is preprocessor, what is the location of the preprocessor. After that, what is the job of the preprocessor. After that, we will talk about whether it is required or not required in a C, C++, and Java. Okay. Let's say one diagram, then why is it not coming? Yeah, it's okay, fine. Okay. Now see this one simple diagram here I'm going to provide about to locate the preprocessor in our programming languages now. For example, I'm going to take the C program. This is my C program. When I say it's a C program, that file extension should be what there? .c. Observe carefully. The file extension is what there? .c. When we prepare the C program, definitely here we have to perform what there? Compilation. Here we need to perform what there? Compilation. This is compilation process. When we perform compilation over C program, there we are able to get .exe files. Here, what we are able to get here after compilation, there we are able to get like what there? .exe files. When we perform compilation, then we have to perform execution. This is like what I'm telling there, execution. When we execute the program, there we are able to get outputs. Some output here we are able to get. When we execute the program, there we are able to get what there? Some output. This is the structure of C programming language what we are following. First of all, we have to prepare a C program. Compilation we have to do. Then .exe files we are getting. Execution we have to do. Then we are able to get the output. I want to see what is going on inside the compilation. I want to understand what is going on in the compilation. Alright, sir. If you open the compilation process here, there nearly 4 missions are working together. To perform the compilation, nearly 4 missions are working together. What 4 missions are working together? First one is preprocessor. Next one is compiler. Next one is assembler. Next one is loader link editor. Right, sir. Next one is what there? Loader link editor. Right, sir. This is like what I'm telling to you. The compilation internal structure. How many phases are available? 4 phases are available. First one is what there? Preprocessor. Next one is what there? Compiler. Assembler. Next one is what there? Loader link editor. These many phases are available. Out of all these phases, now our required phase already we understood. Preprocessor is our required part. Now by this we can understand it. What is the location of the preprocessor? The location of the preprocessor is at what there? Inside the compilation. In compilation, the very first phase is what there? Preprocessor. Okay, fine. My required information I am getting there. It's okay. That's sufficient for me. Not required to continue the remaining part of the diagram. But for future purpose, I want to elaborate internal compiler structure also. For the sake of understanding the future, I want to elaborate internal compiler structure also. Understand it clearly. Now, inside the compiler, if you open the compiler, where we are able to have almost all 6 to 7 phases are available. What phases are available inside these? First one is lexical analysis. Next one is syntax analysis. Next one is semantic analysis. Next one is intermediate code generation. Intermediate code generation. Code optimization. Code generation. Okay. Right, sir. Now overall, these are the phases here what we are having and try to understand it clearly. Okay. Lexical analysis phase, syntax analysis phase, semantic analysis phase, intermediate code generation, code optimization, code generation. These are all the phases here what we are having. Okay. Right, sir. All these steps I don't require immediately. In the future discussion, I need this internal structure of the compiler. That's why I given that elaborated information. As of now, my required point is what the preprocessor location. What is the location of the preprocessor actually? Preprocessor is available inside the compilation. That is what their first phase of the compilation. Preprocessor is available as the first phase of the compilation. Understand it clearly. Right, so now let me take the diagram here into the part here. Later on I'll give that information to you. Right, sir. Now let's move on to the punch here. Preprocessor is the first phase in the compilation. Okay, fine. What it will do? What is the job of this preprocessor in the compilation? What is the requirement of it? Now I'm going to give some clarity. All of you observe carefully. In C and C++, both in C and C++, the complete predefined library, is provided in the form of header files. Am I right or not? Please confirm to me. In C and C++, the complete predefined library is provided in the form of what files? No, header files. Am I right or not? What are the examples for these header files here? What we are having there? stdio.h. Next one is what there? conio.h. Next one is what there? math.h. Like this. All these are like what there? Header files. Sir, all of you get my point or not? What is the point here I'm telling to you? In C and C++, the complete predefined library is provided in the form of header files. Examples: stdio.h, conio.h, math.h, and so on. Nice. In C and C++ applications, in C and C++ applications, to include header files or maybe to use predefined library, we have to include the header files. C and C++ programs, if you want to prepare, no, if you want to use the data files content inside the program, if you want to use predefined library inside the program, first we have to include header files to the C and C++ programs. Okay, in C and C++ applications, to use predefined library, we have to include the header files. To include header files, we have to use hash include statements. We have to use what statements? They now tell me hash include statements. In C and C++ applications, to use predefined library, we have to include header files. To include header files, we have to use what statements? No, hash include statements. Let's understand it clearly. Hash include stdio.h, hash include conio.h. Next one is hash include math.h. Clear? All of you are getting clarity on this? Okay. For example, I prepared a C program. In C program, I have written some hash include statements. Same hash include statements I have written. Then I'm compiling C program. When I compile C program, what preprocessor will do? Observe carefully. Preprocessor will recognize all the hash include statements. Preprocessor will take all the header files, whatever the header files we specified along with hash include statements. Preprocessor will check whether these header files are available or not in C software and C++ software. Inside the C and C++ software, preprocessor will check whether these header files are available or not available. If these header files are not available, preprocessor will raise an error. If these header files are available inside the C and C++ softwares, preprocessor will load the data files content to the memory. Preprocessor will load the data files content to the memory. Loading predefined library to the memory at compilation time is called static loading. Previously static memory allocation, that is different. Now this is static loading. Loading libraries at compilation time is called what there? Static loading. So here the conclusion, in C and C++, preprocessor is required. For what purpose there? To recognize hash include statements and to load header files content to the memory. What is mandatory? What is required? Preprocessor is required. That's the reason why preprocessor is mandatory inside the C and C++ softwares. Come again, what is the point here I'm telling there? If we compile C and C++ applications or programs, preprocessor will perform the following actions. What action that preprocessor is able to perform there? Observe carefully. Point number 1. Preprocessor will recognize all the hash include statements. Preprocessor will recognize all the hash include statements and the provided header files. Then what next one here? Preprocessor will check whether these header files exist or not in the C and C++ softwares. Okay, preprocessor will check whether these header files are exist or not in the C and C++ softwares. If the provided header files do not exist in the C and C++ softwares, then the preprocessor will raise an error. Some error it is able to raise. What error it is able to raise, that doesn't matter to us. What error it is providing, that is not at all required. But definitely we are able to get what there some error if it is not existed. All of you understand it clearly. Next one is if the provided header files exist in a C and C++ software, then the preprocessor will load the header files content to the memory. Then preprocessor will load the header files content to the memory. Understand this note? Note here I'm giving there. Note type of point here I'm telling there. Loading predefined libraries at a compilation time is called static loading. Loading libraries at compilation time is called what there? Static loading. Now tell me, this total process is done by preprocessor. Am I right or not? At what time preprocessor is doing this total work? No. At what time the preprocessor is doing this total work? Is that at compilation time or at runtime? Compilation time. When we compile the program, then preprocessor is performing all these things. No. Everybody understand my point clearly? See that everything is going in. Preprocessor is available in compilation. Preprocessor is doing some work in the sense part of the compilation only. Understand the point clearly now? All right, sir. That's okay now. This is like the point here. What I'm telling there. Now coming to the conclusion. What is the conclusion here? I'm telling to you. In everybody understand it clearly. In a C and C++, in a C and C++, preprocessor is required. Preprocessor is required. For what purpose it is required? No, to recognize hash include statements. To recognize hash include statements in order to load header files to the memory at a compilation time. Right, sir. In order to load header files to the memory at compilation time, we require that preprocessor. This is exactly the requirement of what their preprocessor in C and C++. All of you are getting clarity on this point now. What is the need of the preprocessor in C and C++? To recognize hash include statements and to load the provided header files content to the memory, we need preprocessor. Right, sir. The related diagram also we have given. Now try to understand it clearly. Okay. Now the point is what? Why preprocessor is not required in Java? Why it is not required inside the Java? That point also we have to understand. Let me check for it. I'm going to give another point here about this one. First of all, let me prepare the diagram with respect to the Java. This diagram I'm going to prepare with respect to the Java. Now try to understand it clearly. If it is Java now, you should not provide .c. We should not provide what there? .c. What we are going to provide then? Now here, in place of .c, there we are going to use .java file. File extension must be what there? .java. In C++, .cpp. In the case of Python, .py, py. They are the file extensions. Similarly, when we compile Java file, there we are not going to get .exe file. There we are not going to get what there? .exe file. There we are able to get what files there? .class files there we are able to get. There we are able to get what files? .class files. Understand it clearly. Alright, sir. Then finally we are able to get the output. Then what is not available inside the Java? What is not required inside the Java? Preprocessor is not required inside the Java. That's why that we can remove that clearly. This is Java related parts here. Now let me copy this diagram into our content here. Then after that, I'll go for the remaining part. Okay, fine. Now, understand the point here. Here, what is the point here I'm telling here? Why? 1 minute. So why preprocessor is not required inside the Java? That point here I'm telling you now. First of all, understand it. In Java, in a C and C++, the complete library is provided in the form of header files. But in Java, the complete predefined library is provided in the form of classes and interfaces in packages. Mainly what they're packages. The complete library is provided in the form of like what are their packages. Now, examples for the packages here I'm telling to you. Observe carefully. Java.io is a package. Java.util is a package actually. Next one is what there. Java.sql is a package. The other various packages here what we are having. Inside these packages, no classes and interfaces are available. In that classes and interfaces only the total libraries are available. Predefined libraries. Okay, fine. Next one is if you want to use predefined libraries in Java applications, then we have to include the packages in Java applications. Then we have to include the package in Java applications. Here to include the packages in Java applications, we have to use import statement. In C and C++, what statement there? Hash include statement. But in the case of Java, what statement we are using? No, import statement. To use predefined library in Java program, we have to import the packages. To use that import statements there, then that means to import the packages. No, here we have to use what there? Import statements. What is the syntax of this import statement here? Now observe carefully. Import java.io.star. Next one is import java.util.star. Next one is import java.sql.star. Like this, here we are getting like what their import statements. Import java.io.star, import java.util.star, and import java.sql.star. They are the import statements here what we are getting. All of you are getting it or not? All right, sir. It's okay, fine. Next one is what? After this, if I compile the Java program, what compiler will perform? What compiler will do? In place of the preprocessor, we are having compiler. Compiler will take the responsibilities of the preprocessor. But what is the role of the compiler with respect to the predefined libraries inside the Java? Right, observe carefully. If we compile Java application, then the compiler will perform the following actions. What actions that compiler is able to perform there? Now observe carefully. First, compiler will recognize all the import statements. Compiler will take all the package names. Compiler will check whether these packages are available or not in Java software. If these packages are not available in Java software, compiler will raise an error. If these packages are available in Java software, compiler will not raise any error. At the same time, compiler will not load any package content to the memory. In case of C and C++, preprocessor will load that library to the memory at compilation time. But in Java, compiler will not load any package content to the memory. In Java, compiler is responsible for checking whether the packages are available or not available. If they're not available, raise an error. If they're available, don't raise an error. That's it. But don't load any package content to the memory. That is not the responsibility of the compiler. In Java, who is responsible for loading predefined library? JVM, Java Virtual Machine, is the executor of the Java programs actually. He will responsible for loading predefined libraries to the memory. At the runtime of the application, JVM will load the package content to the memory. Loading predefined libraries at runtime is called what? Their dynamic loading. Loading predefined libraries at runtime is called what? Their dynamic loading. Understand the point clearly? What I'm telling you. Now the point is what there? What compiler will do? No. Compiler will recognize all the import statements and their package names. Compiler will check whether the provided packages exist or not in the Java predefined library or Java software. In the Java software, if the provided packages do not exist in the Java software, then the compiler will raise an error. If the provided packages exist in the Java software, then the compiler will not. Then the compiler will not raise any error. At the same time, compiler will not load any package content to the memory. Any package content to the memory. Compiler will not load any package content to the memory. Right, sir? Okay, fine. If the compiler is not performing any loading there, but who will perform that loading part here? In Java, observe carefully. In Java, at a runtime, JVM will load the classes and interfaces from the packages to the memory at a runtime as per the requirement. That's it. Right, sir? Now tell me, the conclusion here I can give there. In Java at runtime, JVM will load the classes and interfaces from the packages at the memory at runtime as per the requirement. Now observe carefully, note I'm telling there, loading predefined libraries at runtime is called dynamic loading. Loading predefined libraries at runtime is called what there? Dynamic loading. Now coming to the conclusion, what is my conclusion here? All right, sir. Now observe carefully the conclusion. What I'm telling to you, all of you understand it, no? Preprocessor is not required in Java. Why? Because in Java, no hash include statements, no header files. Alternatively, we are having classes and interfaces inside the packages and import statements, which are recognized by compile and JVM and which are loaded by JVM at runtime. That's it. So here we don't require what their preprocessor. Preprocessor requirement is not available. Preprocessor is not at all required in the case of Java. That's the conclusion here, what I'm telling you. Now the point is what there, all of you understand it clearly. That's it. Everybody observe carefully. Preprocessor is not required in Java. Why? Because in Java, hash include statements and header files are not existed. Alternatively, import statements, classes and interfaces inside the packages and import statements are existed. These things are available. Because of that reason, preprocessor is not required. Preprocessor is not required. Understand it clearly now. Right, sir. So this is about the content here. What I'm trying to say about like what the preprocessor and its requirement in C and C++, and it's not required in the case of what their Java programming language. 1 minute, sir. I want to keep this diagram here separately. Right, sir. At the end here, I want to provide this diagram, not try to understand it. Okay. So finally here, the content here, what we understood there, what is that preprocessor and what is its requirement? All the content here we understood clearly. Right, sir. It's okay, fine. Fine. It's okay, no problem. So this part here we understood there. The second difference is also be completed overall in between Java and others. The difference, second difference is also be completed. What is the third difference here? I'm telling to you. Observe carefully. Third difference is what there. Listen, all of you listen carefully. C and C++ are platform dependent programming languages, but Java is a platform independent programming language. But Java is a platform independent programming language. But before this point here, I would like to give one more small point. One interview question here we are missing now. Now let me complete that interview question also. After that, I'll come back to this particular topic. What question here we are missing actually in the previous discussion about this content here? What is that question here I'm telling to you? Observe carefully. What are the differences between hash include statement and import statement? What are the differences between hash include statements and import statement? This is a question actually. This is missing now. Now here we have to understand it clearly. As we understood clearly, hash include statements and import statements. Now here we have to differentiate it now. What is the first answer here now? Now tell me, in which languages both are available now? Hash include statements exist in C and C++, whereas import statements exist in Java. Point number one. Point number two, what they are able to do actually, what hash include statements are able to do, what import statements are able to do now. Hash include statements are able to include the predefined libraries which are available in header files. Am I right? Hash include statements are able to include the predefined libraries which are available in what their header files. But whereas import statements are able to include the predefined libraries. Import statements are able to include the predefined libraries which are available in classes and interfaces inside the packages. That means in the packages some libraries are available. To include them, we are using what their import statement. Header files content, if you want to include, there we have to use what their hash include statements. That's okay, fine. Point number three. Who are evaluating the hash include statements and who are evaluating import statements? Hash include statements are evaluated by the preprocessor, whereas import statements are evaluated by both compiler and JVM. In Java, both are evaluated here, import statements. For checking whether packages are available or not, compiler must evaluate import statement. For loading package content to the memory, JVM must evaluate import statement. Both are going to evaluate that import statements. Next one is after that, point number 4. Understand the point clearly? Point number 4. Hash include statements are supporting static loading. Definitely, hash include statements are supporting what type of loading? No, static loading. Whereas import statements are supporting, tell me what type of loading there? Import statements are supporting dynamic loading. Hash include statements are supporting what their static loading, but import statements are supporting what their dynamic loading. Now one more point here I'm telling to you. By using single hash include statement, only one header file we are able to include. But by using single import statement, we are able to include more than one header file from a single package, where we are using star notation. Their star notation is representing what their all classes and interfaces from the respective package. Already we have used it. Now try to understand it clearly. See this one, import java.io.star. What is the meaning of it now? In a java.io package, number of classes and interfaces are available. I want to include all of them to the present Java file. So more than one class, more than one interface of the java.io package, we are able to include. That is the purpose here we can understand. Now the point is like what I'm telling to you, fifth point. So by using a single hash include statement, we are able to include only one header file. If you want to include more than one header file, then we have to use multiple hash include statements. Multiple hash include statements. Example here I'm telling to you, hash include, they're the same, yesterday.h, hash include conio.h. The next one is what there, hash include math.h. Like this here we are able to provide. But by using single import statement, we are able to include, more than one class or interface of the same package. More than one class or interface of the same package. Say for example, I'm telling to you, import java.io.star. If we provide this, what's the meaning of this one? Now tell me. Java.io.star. Here star is represented, means that all classes and interfaces from java.io package that I'm going to include in my present Java file. All classes and interfaces from java.io package I want to include it to the present Java file. That is the intention of like what there, this import java.io package content. Yes, sir. All of you are getting clarity in this point or not? So this is exactly the points here what we are understanding clearly now. That's okay, fine. After completion of this content here. Now coming to the next thought difference here. What about this thought difference? No, all of you understand it clearly. C and C++ are platform dependent programming languages, whereas Java is what their platform independent programming language. Right, sir. We are going to understand. This is one of the important difference. No, now try to understand this point here. Before going to understand, C, C++ and Java are platform dependent or platform independent before that. First of all, when a programming language is platform dependent and when a programming language is platform independent, that points here we have to understand. After that only we are going to discuss how C and C++ are platform dependent and how Java is a platform independent. First of all, I'm going to give definition for C and C++. That means platform dependent programming languages. Understand it clearly. Again, I'm telling there, if I write a program, two things here we have to perform. One is a compilation, another one is what their execution. Am I right or not? Observe carefully. If any programming language allows its applications to perform compilation and execution both on the same operating system, both must be on the same operating system, then that programming language is called platform dependent programming language. Tell me, what is a platform dependent programming language? No, if any programming language allows its applications to perform both compilation and execution, on the same operating system, then that programming language is called platform dependent programming language. If any programming language allows its applications to perform both compilation and execution on the same operating system, then the programming language is called what there? Platform dependent programming language. Now understand it clearly. Examples for this platform dependent programming language are what there? C and C++. C and C++ are what there? Platform dependent programming languages. How can we say that C and C++ are platform dependent programming languages? I'll give some diagrammatic representation. Now try to understand it clearly. All of you understand it now? I'm going to take again this simple diagram here. For example, I'm going to take what there? A Java file. All of you observe carefully. I'm going to take what there? A Java file. This is a Java file, sorry, C file, .c file, C program. Now I need to perform compilation. Here we have to perform compilation. So now here I need to take what the compilation process. compilation. When we perform compilation here, in the case of C program, when we perform compilation, here we are able to get a .exe file. What file here we are getting there? .exe file. Alright, sir. After this, now here we need to execute this program. To execute this program here, we are going to take like what their execution process. Execution. Who will execute our program actually? C engine will execute this program. C engine will execute this program, then it is what their execution. This is what their execution. When we execute this program, there we are able to get output. There we are able to get like what their output. Directly here we are able to get some outputs. Okay. So this is the total process here. Process about our applications. All of you understand it now? For compilation, I want to use one operating system. For compilation, I'm going to use one operating system. For execution also, here I'm going to use another operating system, same operating system. As per the definition here, what I am telling there, for compilation, if I use Windows operating system, for execution also we have to use what there, the same Windows operating system. Then only C and C++ are what their platform dependent programming languages. Got it or not? For discussion purpose now, I'm going to use some different operating system at runtime, not same as the compilation operating system. Assume it. For our discussion point of view, I'm going to use what their different operating system at compilation. Now tell me that a C engine is available on which operating system? No, Linux operating system. It is able to understand, that C engine is able to understand only Linux representations. Before that, please remember it, from one operating system to another operating system, internal representations are varied. From one operating system to another operating system, internal representations are changed. Everybody understand my point clearly? Now the point is what? Now the point is like what there, what I am telling to you. C engine is able to understand and execute only Linux representations. C engine is able to understand and execute only what representations can know? Linux representations. C engine is able to understand and execute only Linux representations. Why? Because it is available on which operating system? No, Linux operating system. It's available on which operating system? Linux operating system. Okay, fine. Now observe carefully. Now coming to the compilation process, no, C program we compiled on which operating system? Windows. Then immediately, then some executable code will be generated inside this .exe file. .exe file will be generated. What is available inside the .exe file? Inside the .exe file, directly executable code is available. Then what is this code actually? What we are understanding there? What it is actually? Now observe carefully. I'm going to give information to you. Know, .exe file contains directly executable code. Directly executable code. All right, sir. Directly executable code, and it has the local. It has the local operating system representations like Windows representations. It has the local operating system representations like what their Windows representations. That's it. Now these are about the points here what I am telling to you, like what their what representations? No, Windows representations. Please all of you read this statement here. .exe file contains directly executable code. It has the local operating system representations like what their Windows representations. Now this is Windows represented .exe file, but that we are trying to execute on Linux operating system. Is it possible to execute Windows representations on Linux operating system? Is it possible to execute Windows representations or Linux operating system? Linux is having its own conventions. Windows is having its own conventions. Windows data is different. Linux data is different. So because of that reason, that Windows representations are not working, not executable under what their Linux operating system. Got my point around? So because of that reason, then what we have to do, if you want to execute this program, we don't have any other alternative. Only one option. We have to change the operating system at runtime from Linux to Windows. At runtime, we have to provide the same operating system like what there, Linux to Windows. That's it. We are not having any other option clearly. Whatever the operating system we have used for compilation, the same operating system here we have to use in what there for execution. Now tell me, in C and C++, a runtime operating system is dependent on the compilation time operating system or not? Runtime operating system is dependent on what their compilation time operating system. So because of that reason, C and C++ are what their platform dependent programming languages. C and C++ are what their platform dependent programming languages. That's it. That's it. Now everybody understand the points clearly. This is like what their platform dependent programming languages. There's a diagram here given. Now try to understand it clearly. So what is somewhat discussion here? I'm going to provide this one more point here. In a C and C++ applications, that's it. Now, if we compile C and C++ programs in Windows operating system, then the compiler will generate .exe file. It contains directly executable code and it has the local operating system representations like Windows representations. In this context, to run the Windows represented code, that's it. In this context, to execute, to run the Windows represented code, we must provide the same Windows operating system at a runtime. We must provide the same Windows operating system at what time? Runtime. So here it is dependent on what their operating system, compilation operating system. That is the reason why C and C++ are what their platform dependent programming languages. Everybody put more concentration on. Okay, sir, good. This is C and C++ and how they are platform dependent programming languages that we understood. But how Java is a platform independent programming language? How is it possible to say Java is a platform independent programming language? Before that, what is platform independent programming language? After that, we'll understand how Java is a platform independent. That's it. Now let's understand the point clearly. First of all, tell me what is platform dependent programming language? What is a platform dependent programming language? Now tell me. If any programming language allows its applications to perform both the compilation and execution on the same operating system, then that programming language is called platform dependent programming language. Quite opposite of it is what they are, platform independent. What is that quite opposite? No, observe carefully. If any programming language allows its applications to perform compilation in one operating system and execution is in another operating system, then that programming language is called platform independent programming language. Definition here we have to understand. Compilation is on one operating system, execution is on what there, another operating system, then that programming language is what there, platform independent programming language. Now, example for this platform independent programming language is what there? Java. Java is an example for what there? Platform independent programming language. How can you say that Java is a platform independent programming language? What is the reason why Java is a platform independent programming language? Now, let us understand this one. I'm going to show the same diagram here. All right, sir. All of you observe carefully. For example, now here I'm going to take a Java program. Everybody put more concentration here. This diagram is very, very important. Dot Java. I have to perform compilation. I have to perform what there? Compilation. Compilation. When we perform compilation, we are able to get dot class file in Java, not dot exe file. In the case of Java, dot class file. In Java, the file is what there? Dot class file. Now, I want to execute in multiple operating systems. I want to execute in what there? Multiple systems. Multiple executions here I am going to provide. Why? Because it is a platform independent. Compilation is on one operating system and execution is going to be happen in another operating system. So multiple executions here I want to perform. This is one execution. Here we are going to get some outputs. Now observe carefully. Execution, then output. And here we are going to use for compilation we are using one operating system. For execution also here we are using what there? Another operating system. Like this multiple executions here I want to provide. Multiple executions here we are going to provide. Okay, right, sir. Now inside this I want to confirm the operating systems. Now observe carefully. Compilation I want to do on what there? Windows operating system. Execution I want to do on what there? First one is what there? Linux operating system. And another time execution I want to do like what there? Solaris operating system, Sun Solaris. Another time I want to execute it on what there? Mac. Another time I'm going to use the same Windows. Now observe carefully the diagram here. Compilation is on Windows operating system, but execution is going on what there? Multiple operating systems, different operating systems. That execution is going to be happen. Everybody put more concentration here clearly. Compilation is on one operating system and execution is on what there? Another operating system. If it is possible, Java is what there? A dynamic programming language. Sorry, Java is what there? A platform independent programming language. But how is it possible? That's the point here we have to understand. All of you understand clearly. When we compile Java program on Windows operating system, there we are able to get dot class file. What is the nature of the dot class file actually? If you understand the nature of the dot class file, observe carefully. Dot exe file is different, dot class file is different. Dot class file contains byte code. Yes, dot class file contains what code? No, byte code. It is not directly executable code. It is not directly executable code. It is an intermediate code, and it does not represent any operating system representations, including Windows. Try to observe carefully what exactly the points here I am telling there. Dot class files contains bytecode. It is not directly executable code. It is an intermediate code, and it does not represent any operating system representations, including what their Windows operating system. Okay, neutral code is available. But the point is what? If you want to run this neutral code on Linux operating system, Linux representations are required. If you want to execute this neutral code on Solaris, no, that means Solaris representations are required. If you want to run this neutral code on Mac, no, Mac representations are required. If you want to execute this neutral code on Windows, no, like Windows representations are required. Understand here? Again, we are getting mismatch, no. We provided neutral bytecode, but that is not directly executable in all the operating systems. Why? Because if you want to run any code on Linux, no, Linux representations are required. If you want to run anything on Solaris, no, Solaris representations are required. If you want to run anything on Windows, no, Windows representations are required. If it is Mac, Mac representations are required. Exactly. In this particular situation, to make Java is a platform independent programming language. To make Java as a platform independent programming language, Sun Microsystems has provided a set of converters. Sun Microsystems has provided what there? A set of converters. What converters are provided by Sun Microsystems here? Observe carefully. Exactly. In this location, converters are provided. Understand it clearly? So this is one converter. Now here this is another converter. Now this is like what there? Another converter. This is another converter. Right, sir. Now let me provide all of them. These are like what they're converters. All these are like what they're converters. What is the job of this particular converter actually? This converter will take neutral bytecode as an input and convert into Linux representations. That Linux represented bytecode is called as what their native code. That Linux represented bytecode is what their native code. Linux, Solaris represented bytecode is what their native code. Mac native code and Windows native code. Now, what is the job of this converter? This converter will convert neutral bytecode to Solaris representations. What is the job of this converter? It will convert that bytecode to the Mac representations. Understand my point clearly? Mac representations. That Mac representations are executed and we are able to get the output. What is the job of this converter? Converting that neutral bytecode Windows representations and executing that Windows representations, and there we are getting what their outputs directly. Here we are getting outputs. Understand my point here? First of all, we provided neutral bytecode that we provide to converter. Converter will convert that neutral bytecode into the local operating system representations. Got it or not? But how these converters are provided by Java? Where these converters are provided by Java? Understand it clearly. Sun Microsystems has provided this conversion mechanism and execution process in a single device. Understand my point here? Sun Microsystems has provided this conversion mechanism and execution in a single component inside the Java. This conversion mechanism and execution must be provided in a single component inside the Java. Now the single component inside the Java is called JVM. That internal component to provide conversion and as well as execution is what there is a JVM. Answer my point clearly. Is what there JVM. Now I'm asking one question to all of you. Try to answer for it. What is the question here I'm getting there? Java is a platform independent programming language because of JVMs only. Java is a platform independent programming language because of what there JVM. Now I'm asking one question. Try to answer for it. No. How many JVMs are utilized here? Now tell me in this diagram. One time we are compiling the program and 4 times we are executing the program here. All right, how many JVMs here we have used there? Is it 1 JVM or 4 JVMs? Is it 1 JVM or 4 JVMs? Answer is 4 JVMs. Answer is what there? 4 JVMs. Why? Because Java is a platform independent programming language because of JVMs only. But JVM is a platform dependent. JVM is what there? A platform dependent. JVM is not like platform independent. JVM is a platform dependent. First JVM is a Linux based JVM. Second JVM is a Solaris based JVM. Third JVM is a Mac based JVM. Next one is what there? Windows based JVM. Not only JVM, the total Java software. Java software is a collection of components. The total Java software is like what there is a platform dependent. Java programming language is platform independent. Java program is platform independent, but Java software is what there? Platform dependent. Java software is what there? Platform dependent. That's enough. This is exactly the points here what I am telling there. Right, so just wait 2 minutes of time. I'll complete this discussion also now. Here the point is what? If we compile Java program in a Windows operating system, for example, in Windows operating system, then the compiler will generate dot class of files, where the dot class of files contains, where the dot class file contain, when we compile a Java program in Windows operating system, then the compiler will generate the dot class files, where the dot class files contain bytecode. Yes sir, what it is? No, bytecode. It is not having the directly executable code. It is not having the directly executable code. It contains an intermediate code, and it is not having any operating system representations including Windows. We compiled on Windows operating system including Windows. No operating system representations are available. Right, so now in this context, to execute bytecode in any other operating system, in this context, to execute bytecode, to execute neutral bytecode in any operating system, then the bytecode must have the local operating system representations. Now I'm telling there, in the above context, to make Java as a platform independent programming languages, to make Java as a platform independent programming language, Sun Microsystems, or maybe Java has provided a set of converters along with the execution process, a set of converters along with the execution process in a single device called JVM. The single device is what they're called JVM. That's it. Now understand the point here. Next one here. No, I'm going to give conclusions. Java is a platform independent programming language because of JVMs only. But now tell me, what is the point here? But what is it? No, but JVM is a platform dependent. JVM is what? The platform dependent. But JVM is what? The platform dependent. Note I'm telling to you. What is that note here? Not only JVM, the complete Java software is a platform dependent. Complete Java software is what there is a platform dependent. Is that all? I forget my point now. Java is the platform independent programming language because of JVMs only. But JVM is what there? Platform dependent. Not only JVM, the complete Java software is what there? Platform dependent. That's now this is a content here. What we are thinking now. After completion of this total diagram and all these things now, here we are having one important interview question. What is that question here we are having there? All of you understand it now? Question is, what are the differences between what are the differences between what are the differences between .exe file and dot class file? What are the differences between .exe file and .class file? This is exactly the another question here on the basis of this particular topic. Okay, so this part I will discuss with you on tomorrow. This part I will discuss with you on what there tomorrow. Okay, and I think some of your new members know I'm giving clarity within a few days of time, within 1 or 2 days of time. I'm going to take your classes at what time? 8:30. Please remember it. Now, as of now, I'm taking these few classes at 7 o'clock. Maybe within 1 or 2 days of time, I'll give that announcement maybe on tomorrow maximum. And which date onwards, I'm going to take the class at 8:30. 8:30 to 10, I'm going to take your classes now. You have to attend for the class at what time here? 8:30 to 10 now. Just only few demo class I'm taking at 7 to 8:30. I think day one onwards, I'm giving this announcement now. Try to remember this punch. Okay. That's it. Thank you. Tomorrow at 7 o'clock only class is going on, and tomorrow I will give announcement on which date onwards we have to attend for what there 8:30 classes now. That's it. Thank you. Thanks a lot. We'll meet on tomorrow. Yeah, daily duration is 1.5 hours. 1.5 hours we are going to take the classes now. Okay. Thank you. Guys, then very soon the link is going to be expired. Then please register for the courses immediately as per our requirement. Okay. Thank you.